So the last time we met, I think we were looking at the course structure, data communication network. We look at fundamentals of communication network. And so there were some parts, we defined a computer network, data communication, the components that normally take part in the communication itself. Then the different way we can represent data, text numbers, images, audio, video. Then types of connection, point to point and multi-point. We also look at physical topology. That is how the network is arranged. Look at mesh, star, bus, ring, tree topology, and hybrid. Then we also looked at the concept of a computer network, what it means, types of computer network, local area network, metropolitan area network, then wide area network. And the network architecture. This is the part we are looking at, the physical and logical design of the software, hardware, protocols, information link control standard, topologies, and media for the transmission of data. And we talked about peer-to-peer and then client server. That was for our first class, of which I have not sent you the notes, but I'll send you today. I'll send you the note today. So we now start with the second and third classes for today. So for the second class, we'll be looking at Telecommunication Network Part 2. And various network models have provided the business community with the needed knowledge on the operation of network devices and the layer they are located. And these networks need to be protected from external and internal attacks using what you call firewalls. So in our class, we learn about the network models and how firewalls protect a network. The most important notable models are the OSI, which we talked about in our last class, Open Systems Interconnection Model, and the Internet model. We did not talk about that. The OSI model is made up of 7 different but interconnected layers, while the Internet model has 5. So for the OSI model, we looked at the application, presentation, session, transport, network, data link, and physical layer. Then the second one you call the Internet model is actually called TCP/IP model, which helps to transmit images from one point to the other in a network and is guided by a set of rules that we call protocols. Maybe some time ago, we could say that businesses usually buy communication equipment from one vendor because of incompatibility between vendors. What it meant was that when they were buying communication equipment, they discovered that if they buy from different vendors, there was not a communication among the equipment. So they normally buy from one vendor. If it was IBM, they are sure of buying from IBM. So other vendor products will not be able to sell. And it caused a lot of problems. So all the equipment today, they now use a common standard, which we call TCP/IP standard. TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. And what do we mean by a protocol? A protocol determines how to communicate, what to communicate, and when to communicate. What it means is that it's a set of rules that determine how a network can operate, a set of rules. And these rules determines how to communicate, what do you communicate, and when do you communicate. TCP/IP has a suite of protocols, and the major ones are TCP, Transmission Control Protocol, and IP, Internet Protocol. What does TCP do? It's responsible for moving data among computers. Yes, TCP is responsible for moving data among computers, and it establishes a connection among computers, arranges how packets are to be transferred, and deliver acknowledgement for packets sent. Since the message you are going to send will be bulky or big, they are normally divided into smaller parts called packets. So the TCP part divides this message into smaller components called packets. The IP part now envelopes and addresses these packets so that they can be moved across the network. So you can have a message that's about 10 pages long, and it could be divided into about 100 packets. And they are all sent through different routes on the internet to get to their destination. And that is why sometimes when you are opening these messages on a computer, they slowly get opened. You now see some parts are coming like that, little by little. So that is how it works. So when we compare TCP/IP and the OSI modem, can be said that the host to network layer is similar to the combined physical and data link layer. The internet layer is similar to the network layer, and the application layer provide the same functionality as the session layer, presentation and application layer with the transport layer in TCP/IP, taking care of some functionality of the session layer. So this is the TCP/IP. You have the application layer, which enables client application programs to access the other layers and defines the protocols that application uses to exchange data. You have the transport layer, responsible for providing the application layer with communication and packet services. You have the internet layer, responsible for addressing routing and packaging data packets called IP diagram. Then you have the network interface, responsible for placing packets on and receiving them from network medium, which could be any networking technology. Transmission media. We have various types of medium used in the networks, which include twisted wire, coaxial cables, and fiber optics. This transmission media, for this particular one we are mentioning, they are physical transmission medium. And so each of these medium has its own advantages and drawbacks. And these media are varying speeds, which depends on the implementation. So we look at the twisted wire. Twisted wire is one of the oldest medium of transmission, which is made up of strands of copper wire twisted in pairs. They are normally two. They come together, they are twisted together, and then you now use a bigger cable to now house them. These wires are used mostly for analog communication in buildings, even though they can also be used for digital communication. Twisted pair cables like C85 used in today's LAN can attain a speed of up to 1 gigabit per second. And the maximum distance a twisted wire cable can cover is 100 meters. The second one is coaxial cable, which is just like those used on televisions. It is made up of thick insulated wire that transfers a higher volume of data than the twisted pair. And this was put in use in earlier LAN and covers a distance or more than 100 meters. It has a speed of up to 1 gigabit per second. That is coaxial cable. In fact, the one that people that is desirable more than the others now is the fiber optics. Fiber optic cable consists of bound strands of clear glass fiber. This glass fiber, the wires inside, they are as thick as the human hair. If you can remove a strand of human hair, that is what a fiber optic cable looks like. At the transmission stage, changes the data into pulse of light, which moves through the optic cable with the aid of a laser device with a speed of 500 kilobit per second to several trillion bits per second. Fiber optics is more efficient and faster than the wire medium, making it suitable for systems that transfer huge volume of data. However, this type of cable is very, very expensive, with difficulty in installation than the other media discussed. Then, apart from the wire transmission, when you talk about wire physical transmission, you are talking of how computers get connected to other devices, the kind of wire they use. But not all computer uses wire. Some, in fact, don't use wire. So what if I don't want to go to wireless? Wireless transmission, it uses radio signals with varying frequency. And three types of wireless networks are used by computer. We have the microwave, we have the cellular, and we have the Wi-Fi. Probability is that any of you may have used the three, combination of the three before now. Microwave system, both terrestrial and celestial, they transmit higher frequency radio signal through the atmosphere, which is employed for large volume, point-to-point communication. Microwave example is your base station. For your telecommunication network, the base station, they use microwave transmission. Each of these base stations communicate with each other. If you really look at them, they are placed with the antenna facing each other. So this one will collect the information and send to the next one easily. So this type of signal follows a straight line and does not bend with the curvature of the Earth. So a long distance transmission system requires stations to be placed at 37 miles apart. And the signals here can be analog, digital, and hybrid. Analog, digital, and hybrid. Excuse me, this is supposed to be, sorry, supposed to be analog, digital, and hybrid. Analog and digital signals have been used for communications in all networks. Analog signal resembles a continuous waveform which passes through the media and always used for voice communications. Common analog devices are your speakers you have on your television, you have connected to your radio, even your phone, headset, and they create analog waveform. So analog signals are the ones that carry signals away from the computer, maybe through a telephone, like that. Those ones are analog. A digital system is a discrete binary waveform rather than a continuous waveform. Communication in a digital signal is the form of two distinct states, 1 and 0 bits representing on and off. So anytime the electrical pulses on the computer goes on, that is 1. When they go off, that is 0. With computers using digital signals, they need a modem. The modem is a modulator demodulator to carry out the conversion from digital to analog, which will be sent over telephone lines, cables, or wireless mediums that uses analog signal. Modems help computers to share information using analog signal. Fortunately for us, for those that are buying computers today, they no longer buy modem or pay separate price of modem. Anytime you buy a computer, be sure that the modem is already embedded in it and installed on your motherboard because they are getting cheaper, so they install them. They are the devices that are responsible for converting whatever signal you have inside the computer to a signal that the telephone can understand. It moves it out. When it gets to its destination, it now sends it to the computer, which the same equipment, the same modem attached to the receiving computer will now convert it from analog back to digital, which the computer understands. Then we look at the firewall. A firewall is a network service that controls data flow between network segments using OSI layer 3 to secure the network. In other words, firewalls combine hardware and software in controlling the movement of data from either direction. Firewalls deny unauthorized users from accessing vital information. They are checkpoints where messages from other networks are checked, and they are either turned back or allowed to their destination. Firewalls, they have certain rules that determine the traffic that will go through and those that will be blocked. Most firewalls have implicit denial rule, which is checked against an incoming request. If no rule allows the request, then it is denied. Firewall is installed between an organization's intranet and the internet. They can also be deployed to secure some segments of organizational network from the other segment. This is an example of a firewall. You can see the computer network accessing the internet. Firewall is here. The firewall accesses all users' credentials before they can access the network. It examines names, IP address, application, and other characteristics of incoming traffic. This information is checked against the rules set out by the administrator, and it protects the network from unauthorized access. In very large organizations, the firewall is usually situated on a dedicated computer that is separate from the rest of the network, thus preventing access from private network users. Several firewall screening technology include static packet filtering, stateful inspection, network address translations, and application proxy filtering. They are often used together with the firewall to protect networks. Well, then when you get to your computer, you also have another component called Windows Defender, which also is added to your firewall to improve your security. Packet filtering. Packet filtering assesses certain fields in the header of data packet that flows from a trusted network and the internet. Different types of attack can evade this type of technology. Stateful inspection. It provides extra security as it determines if a packet is coming from an existing communication among two parties. In set of state tables for tracking information from different packets. This inspection either accept or reject a packet if it is a party to a certified conversation or they are establishing a new connection. Network address translation provides additional layer of protection when static packet filtering and stateful information inspection are needed. Network address translation hides the IP address of the organization computers, preventing them from being compromised. Firewall application proxy filtering. Application proxy filtering. Application proxy filtering assesses the contents of a packet. A proxy server denies access to external packets, restricts packets coming from outside the organization, evaluates them, then pass a proxy to other sides of the firewall. If an external user tries to establish communication with a user in the organization, the external user communicates with the proxy application, which in turn communicates with the organization's internal server. Likewise, those within the organization will also have to pass through the proxy to communicate with the outside world. To set up a firewall using Windows 7, this is just a practical step. Follow these steps to set up a firewall. For your firewall, 1, set up system and security settings. From your start menu, click Control Panel. That's on Windows 7. Click Control Panel, then click System and Security. When you click System and Security, you now go under Windows Firewall. Select either Check Firewall status to determine whether the firewall is turned on or off, or allow a program through Windows Firewall to allow a block program through the firewall. 2, select Program Features. Click Turn Windows Firewall on or off on the left side menu. Configure the settings for your home or work or private or public network. Click OK to save your changes. Do we have any question? Any question? Any question? Too bad. Okay. What we'll do, we have 2 classes for today. This one is okay. You wanted to say something? You want to say something?
My end.
Your end, what is that?
No, I said there is no question from me. You're asking if there's any question.
Okay. That means the class, this particular class, maybe because I didn't add more material, it seems rather fast. It's supposed to be fast like this. It's supposed to be 1 hour full. 1 full hour. But it's taking about 40 minutes, which is not too good. So next week we'll stretch it more. We'll just do a 2-hour class. By the time we get to next 2 weeks, we'll catch up. So we can continue with our normal pace. If you have no questions, I'll terminate the class. Then the second class is supposed to be by 6. But because we still have time, we can choose to start by 10 minutes to 6 so that we can finish on time. If it's okay by you, let me know.
Okay, sir, it's fine.
It's okay with me. 5 AM is okay with this.
So we'll start the next class 10 minutes to 6. You use the same login.
So like a 10 minutes break.
Yes. You use you use the
Okay,
same
sir.
login credentials to come in.
Okay, sir.
Okay, see you later.